Hi folks, welcome back. So I'm just recording another short video, this time demonstrating how to do one-way independent groups ANOVA using SPSS. So I've got an SPSS data file up in front of me, and it's got some data. I think it's made up data, and it's an example from the Andy Field textbook. So the data file is puppies.sav, and there are 15 participants is the idea. Here's this person variable, and there's a categorical variable called dose that's got 3 levels, 1, 2 and 3, and then this scale variable called happiness. So that's some sort of happiness rate measured on a scale of, I think, maybe 1 to 10 or something like that, from least to most happy. The dose variable though relates to exposure to how much time someone spent with a puppy. So 1 is like a control, 2 is 15 minutes, and 3 is 30 minutes. So if I toggle, you can see what they are. So control, 15 minutes and 30 minutes. And I guess the idea here is that the more time someone gets to interact with and play with a puppy, then the more likely they are to be happier, so they'll give higher happiness ratings. So we've got a design here that's suitable for a independent groups ANOVA. So participants in one of 3 conditions. We're comparing 3 groups, and we're looking at mean scores on some scale variable. Okay, so there are a couple of ways that you can run one-way ANOVA using SPSS. I'll demonstrate both in this video, but the first way is kind of like the simplest option for a really basic design like this, where we've just got 3 groups, 1 independent variable and 1 dependent variable. And to do that, I'm just going to click on Analyze, Compare Means and Proportions. And this is kind of the route you usually take when we're looking at something like t-test, but you can see there's also this one-way ANOVA option. So if I click on that, we basically just have to select our dependent variable and our independent variable. So our dependent variable is happiness. In this case, we're going to move that over to the dependent list. So our scale variable, our outcome variable, if you like. And our independent variable is the categorical variable, the different groups that people are in, which is this dose of puppies exposure to puppies control 15 or 30 minutes. So if I move that over to this factor box there, a couple of things to note here. Estimates of effect size are already ticked. So if I'll leave that selected, what that will give us, using this route, it will give us eta squared as a measure of effect size. It's quite common to use eta squared or partial eta squared as a measure of effect size for ANOVA tests. With the second way that I demonstrate how to run this analysis using the general linear model approach through in SPSS, I think that gives us partial eta squared. But I believe this one will give us eta squared. Okay, so a couple of things to look at here. If we click on options, we're going to ask for descriptives. We want to do a Levene's test as well. So we want to know if we can assume equal variances for the scatter around the group means. So I'm going to select homogeneous variance test. Depending on the output of that homogeneous variance test, we might need to use a stricter ANOVA test rather than just the basic ANOVA. And if we did, we want a robust ANOVA, we could use either Brown Forsyth or the Welsh test, and we can select them here. So I'm going to select the Welsh test. It's not necessarily the case that we'll need it, but what we might find is if the Levene's test for homogeneous variance is significant and we can't assume equal variances, then we'd want to use Welsh's test. We'd want to interpret Welsh's test. I could run the analysis, check Levene's test, and if it's significant, run it again and select the Welsh test, but I can set the whole thing up in one go and just select all the things I might need and just interpret the things I do eventually need. So I'll click on continue. If we get a significant ANOVA, remember we've got 3 groups here, so the ANOVA is just an omnibus test. It will only tell us there's a significant difference between the group with the highest and lowest mean, but we want to compare all pairwise comparisons of groups. So group 1 with group 2, group 1 with group 3, group 3 with group 2. So we're going to need some sort of post-hoc test that's going to correct the significance level, our alpha criterion, so we're not making some sort of type 1 error by doing multiple comparisons. So We've got a number of options here. If we select that post-hoc option, we can select Bonferroni, we can select 2 key if equal variance is assumed, but we've also got this equal variance is not assumed. So if we get significant Levines, we can't assume equal variances. We want another one of these tests down here. So I'm just going to select Bonferroni. So if we get a non-significant Levene's test and we get a significant ANOVA, I'm going to use Bonferroni corrected comparisons. But I'm also going to select an equal variance is not assumed. So if we get a significant Levene's test, we interpret Welch's test. If that's significant, then we also want a robust post-hoc test. So the one I'm going to select is Games How. Okay, and click continue. I think there's one other thing I might, if I click on that. One thing I missed here, if I go back into options, is I'm going to select means plots as well, because that give us a useful visualization of the group means and the differences between them, which can be helpful for interpretation. So if I click continue, click OK, it's going to run the analysis for us. It's going to give us our output in a separate output window, as SPSS always does. And you can see here it's given us a number of different tables. Let's work through them in order. The things that we will need. So first of all, it's given us a table of descriptive statistics. So you can see the ends for each of our groups, 5 in each group, and it's given us the group means. So if we look at the group means there, control has a mean of 2.20, which is the lowest. 15 minutes had a mean of 3.20 in terms of their happiness rating. This is obviously 30 minutes exposure, mean of 5. So a difference between groups, but we'll have to look at our ANOVA to see if those differences in mean happiness scores are significant. If we look at standard deviations, though, we can see they're all quite similar. So standard deviation for around the mean for control group 1.304, same for the 15-minute group 1.304, 1.58 for the 30-minute group. So not massively different in terms of the standard deviation. That's probably going to give us an indication of what we'll see when we look at the Levene's test. And when we run an ANOVA, it's quite convenient that it gives us our Levene's test in a separate table, which is this test of homogeneity variance test here. And you see it gives us a Levene's statistic, the degrees of freedom, and an associated significance value. So in terms of which test, it gives us 4 different tests for Levene's. In terms of which one we interpret, you could use based on the mean or based on the median. I think there are arguments in favour of both. I frequently just use the bog standard based on the mean, but based on the median is kind of a slightly more robust version because it's not influenced by extreme scores as much. So let's just use based on the mean in this case, though. We've got a Levene's test statistic of 0.092 for this data, and a significance of 0.913, so a non-significant Levene's test. So what that's telling us is the fact that it's non-significant. It's telling us that we can't reject the idea that the variability around the groups is about the same. So we can assume equal variances in this case, and given that, it's then safe for us to we can assume we've probably met the assumption of homogeneity variance. And we can interpret our standard ANOVA model. And to do that, we can just look at this first table here. And that shows us, you can see here we've got an F ratio of 5.119 and P is equal to 0.025. So we've got a statistically significant ANOVA model. And if you remember from the lectures, so this ANOVA, the F ratio, it's a ratio of the between groups variability divided by the error or within groups variability. So if you look at these mean square values here, 10.067 for the between groups, 1.967 for the within groups. If you divide 10.067 by 1.967, what you will get is this F value here, 5.119. Okay, so we've got a significant ANOVA. All that's telling us is that there are significant differences between our groups, and all we actually know from that is that control and 30 minutes must be significantly different because they have the lowest and the highest mean. But we need to follow this up now and consider what about differences between control and 15 and 15 and 30. So to do that, we can look at our post-hoc tests, and the one we'll use is Bonferroni because we We add a non-significant Levines, we can assume equal variances, we use the standard ANOVA, and the post-hoc test is this that we're going to use in this case. It doesn't need to be the robust one, the Games Howell, so we just use Bonferroni. And we can see from this one, you've probably seen these tables a number of times now, these pairwise comparison tables, and they control it. They compare each group against another group, look at the difference between the means, and whether that difference is significant. So if we look at the control group compared to 15 minutes, we've got a mean difference here of -1 and a significance of 0.845. So no significant difference between control and 15 minutes. If we look at control compared to 30 minutes, we've got a difference of -2.8 and p is equal to 0.025. So those were the two we knew were going to be significant. So that is a significant difference. So control and 30 minutes, significantly different means for those groups. The last comparison, we want to compare 15 with 30 minutes. We get a mean difference of -1.8 and p is equal to 0.196. So not a statistically significant difference between 15 and 30. So what we're seeing here is of the three groups, there's only one pairwise comparison that's significant, and that's the control and 30 minutes. And to interpret what that means, we can use we could look at our plot of means that we asked for. So what we're seeing here is that this control group mean and this 15-minute mean are not significantly different from each other. This 15-minute mean and this 30-minute mean are not significantly different from each other. The only ones that are control and 30 minutes. They're significantly different in terms of the mean happiness score for participants. And the other way we could have given context to that is just by looking at these group means, and we would usually report those group means. So in terms of effect sizes as well, we gave us a table of effect sizes, and it's given us a point estimate there for eta squared of 0.46. So that would probably be a large effect size in this case. Okay, so that is one way. We didn't hear this other table here, and I didn't mention because we didn't need it. It gave us our Welsh's test, our robust ANOVA on a separate table. We didn't need it because the Levine's test wasn't significant, but it's there. It would have been there already should we have needed it. You can see here it's more robust in the sense that it uses a stricter test by adjusting the degrees of freedom, the error degrees of freedom down. So they're 2 and 7.94 for the Welsh test. If we look at them for the standard ANOVA, they're 2 and 12. Okay, so it's made the test stricter. All right, so that's one way of running this analysis. There is another way you can run the same analysis. I'll do it on the same data. We will get the same results, but we'll get some slightly different output. And to do that in SPSS, we use the general linear model approach. So I'm going to go analyze, general linear model, and the one we want is univariate. It's a univariate test, so general linear model univariate. And it gives us this pop-up box. It's asking us for our dependent variable, which is obviously happiness again. And our independent variable is labeled as fixed factors. Our IVs are fixed factors in this case, and we can select a number of options here. Let's click on plots. I'm going to move dose over to this horizontal axis and click add. What that will do is give us a plot of means similar to the one we've got here already from the previous version that we did. If I click on options, we'll ask for descriptives. Estimates of effect size, that will give us partial eta squared, and because we've got an independent groups design, we'll ask for homogeneity tests. That will give us our Levine's test as well. Click continue, and the last thing we'll do is we'll select a post-hoc test. So if I click on post-hoc tests, we're going to select dose and move that over, and we're going to select post-hoc test for dose. So I'm just going to select Bonferroni. We know that because we've just run this analysis using a different method, we know that the Levine's test is not going to be significant, so we're not going to need Games Howell. And if I click continue, click OK, that's going to run that analysis for us. And you can see that it's now labelled, rather than above it was one-way ANOVA, now it's saying univariate analysis of variance. couple of different tables. It gives us our ends for our categories. And this first table gives us our descriptives, means, standard deviations, and ends. In the second table, similar to what we got above, gives us our Levene's test again in a separate table, and that's still the same. So we've got a Levene's statistic of 0.092, p is equal to 0.913, so it's still non-significant. That's going to be the case because we're using the same data set. So we've got a non-significant Levene's. We can assume equal variances. And our ANOVA on this occasion, the result of our ANOVA test is in this test of between subjects effects table, because we're using a between subjects independent groups design. And a couple of things to note here. So to find the actual ANOVA results, we look at the kind of independent variable label here in this row, dose, and then that gives us our associated F value 5.119 and our significance 0.025. So again, we're seeing that we've got a significant ANOVA model. Another thing to note about this table, though, is it's given us our measure of effect size partial x squared as an extra column on this between subjects effects table, and it gives us partial x squared of 0.46. So that is, it's given us exactly the same effect size as eta squared did. Partial x squared and eta squared, they're calculated in slightly different ways. I won't go into too much depth about them, but what we're seeing here is still kind of a large effect size. One other thing to note about this table is we've got this top line here, corrected model, gives us an F value and a significance, and I think this is kind of the robust model. So if we weren't able to assume equal variances, we could interpret our F value from this corrected model. It turns out to be exactly the same in this case as our normal univariate F test. But one thing to note about this option, when I set it up, there wasn't the option to choose Welch's test. So I think if you ran your test this way and you wanted Welch's ANOVA as a well-established, more robust ANOVA test, what you'd have to do is go back and run it the other way using the analyze, compare groups, one-way ANOVA option that we did first. Okay, so what we know so far, we've got a non-significant Levene's test. We can safely meet the assumption of homogeneity variance, so we can interpret our standard ANOVA model. We get our F ratio of 5.119, and we've got a significant p-value of 0.025. So we need to do these post-hoc follow-up tests. And here it's given us our Levene's test, our Bonferroni post-hoc multiple comparisons table, same as we got above, but it's obviously a much smaller table because it only asks for Bonferroni. It's given us control compared to 15 minutes, and that's not significant. Control compared to 30 minutes, that is significant. 15 minutes compared to 30 minutes, that's still not significant. So the exact same results, just two ways of running the same analysis, and there's the plot of means. Again, helps us interpret what we're seeing. So the only significant difference we're seeing in this data set is between the control and 30 minutes treatment groups, and the 30-minute treatment group had statistically significantly higher happiness scores than the control group. Okay, so that's enough talking from me. I'm going to stop talking now, and I'll record more of these types of videos soon. Thank you for watching and listening.